Hello everyone, myself A. Brahmanand Reddy. Now I'm explaining about Java exception handling. So now today my objective it is to make you to learn about exception, what happens when an exception occurs, benefits of exception handling framework, so catching exceptions with try catch block, so catching exceptions with finally block. So now what is an exception? What is an exception? So now exception it is just like an event. It is just like an event which is unexpected. An unexpected event which occurs at the execution time of a software or a program or an application is said to be an exception. It is general in a general case we can say something as an exception which we does not expect, which we does not expect. The same way, an unexpected event which occurs at the execution runtime of any application we say as an exception. So that is the first one, that is exceptional event. So unexpected event, error that occurs during runtime cause normal program flow to be disrupted. Unexpected event which will disrupt with the mainstream of execution. So now these are few of the examples. Divide by zero errors, accessing the elements of an array beyond its range, invalid input, hard disk crash, or opening a non-existing file, heap memory exhausted. So let us see how we can handle those. So let us take an example like this. Now here in the statement, here in the println statement 3 by 0, it is said to be divide by 0, isn't it? Now what is this? Divide by 0. Anything divided by 0 it becomes infinite. In other programming languages like C, if it is divided by 0, it goes to the uninfinite exceptional case such that it won't come out of the execution environment. So now, how can we handle this? Now here, the JVM will handle this initially. So default exception handling. So there is a concept called default exception handling in JVM. Now this handles the unexpected event which has occurred. Now what is an unexpected event? Here we can see here it is as 0 at, that is divide by 0. This is now as, you see, this is now an error. Now it is showing as an exception. So now what is this exception? It is in the arithmetic operation, now, isn't it? Division is nothing but arithmetic operation. So it is said to be arithmetic exception. Now here it is a class. Here it is a class. When we execute that previous program, now this program here, it generates an error at the execution time, that is not at the compile time, at the execution time. When we execute using the Java interpreter, it will generate this error. We say it as an exception. So now it is at line number 3. You can see that it is at some line number 3. Now it is showing that line number, and the program name it is divide by 0.java. And default exception handler, it is provided by the Java and runtime environment. This JVM provides that by default there will be a default exception handler. It prints an out exception description. It gives description here. We saw that. Now this is a description part of that exception, that is error. It generates a stack trace. It generates a stack trace. Now what is a stack trace? Hierarchy of methods where the exception occurred. So it is the hierarchy of methods where the exception occurred. We say it as a stack trace. We will see later. So it causes the program to be terminated, and the statements beneath this won't execute, and it stops the execution environment. It terminates the execution. Now that is the last point here. And next. So what happens when an exception occurs? When an exception occurs within the method creates an exception object and hands it off out of the runtime system, creating an exception object and handling it to the runtime system called throwing an exception. So that is nothing but previously when there divided by 0 error has been occurred, there it generates an instance of arithmetic exception, and it will be thrown and it will be caught by the default exception handler, and now after that it displays that description part of that exception which is there in the instance, that is about divided by 0, and it is said to be, it is called by which class? Arithmetic exception. It is called by the arithmetic exception class. It is called by arithmetic exception class here. Now it displays that and it terminates. Now it will be thrown. Where it will be thrown? It will be thrown at this point. It will be thrown at this point. Because here it is an exception here. It can't execute. It can't execute divided by 0, isn't it? And now it will be thrown. And after that it will be called by the respective class. Now this is the class arithmetic exception, which is defined in the lang package of Java. Now that is nothing but how can a class can be handled? Using an object, isn't it? Now it creates an instance of that class such that here it will throw the respective instance. Here it throws the respective instance of that exception class. So that we need to understand here. So this is the stack trace. If the method is somewhere else, then the method, it can be handled in the main method itself. The exception can be handled in the main method itself. How? Maybe it is in this method. The exception may be in this method. It will be thrown to this method. It will be thrown to this method. It will be thrown to this method, and as per the execution, it will show the trace where the exception has been occurred. So we can see that in the execution environment. Now this is a stack trace. So when an exception occurs, it can be handled. Exception handler chosen. It will catching the exception. Let us learn how we can catch an exception. So here it throws an exception. It finds an exception, and somewhere else, here or here, wherever the method. So when there is a method call, using that method call statement, we can use that to catch that exception wherever we want. So these are different types of exception classes. We can see that super class of every exception, we say it as a throwable class. A throwable class. So there are two different types. One is the error, and next one is there are two different types of errors. In general case, it is an error, and second one, it is an exception. The exception, there are four different types: IO exception, class not found exception, clone, supported exception, runtime exception. Here in the runtime exception, these are different classes. Here in IO exception, these are different classes. So benefits of exception handling framework. The exception handling framework, it will be benefited by, we can handle that. So somewhere else we cannot. For example, if we develop an application somewhere else in the input, in the text box, a user by default unexpectedly he gives in a calculator, for example in a calculator application, unexpectedly a user may give input for the second value as 0 in the division operation. Then how can we handle that? Using this exception handling, we can handle that. So these are different types. So how can we separate and how can we integrate? Let us come to the main point. So we can use exception handling in Java in this way. There are 5 different types of keywords in exception handling. One, it is try, and next one it is catch here, and next one it is final, and next one it is finally, that is the third one, and next one throw and throws. Those are 5 different exception handling keywords which are there in Java. Now this is a try catch block. So when we expect there is a exception, we need to aggregate that code into the try block. We need to make that code to be separated from the main code, and it need to be it need to be segregated from the main code, and it need to be provided in a try block, such that the try block need to have some catch block. What does a catch block contain? A catch block contain a formal parameter as an exception instance. What is an exception then? So exception, when there is an exception generated, exception throws exception instance of that type. So now we need to catch that exception. So in that case, we need to have catch block with that exception instance. So here, that is an example. Here there is a throws block. So if the method throws an exception, we can use like this. So grouping and differentiating error types. There are different types of error. This is one of the error, file not found exception. This is one of the exception here. If we use a input taking a file, if it is not found, we can use this exception. Grouping and differentiating error. So we can use IO exception for some other exception handling instances. And next, let us come to the main phone try catch block. So now a try block contains some code which is monitored for exception. A catch block contains the respective instance of that exception class which may be generated, which we expect to be generated. So in this way we can use here, I have forgotten to explain this. So here we have two different types of catch blocks. So a try block can generate many number of exceptions, I mean n number of exceptions, such that we can handle that code according to the logic of generated exception using the respective exception classes, that is exception instances, creating like this. Now a try block can contain any number of n number of catch blocks to the respective exceptions we expect in the try block. So here we can handle this divided by 0 error which we expect as in the first program. In this way we can write here the arithmetic exception like this, creating an instance for that, taking a catch block or a try block. We can handle here that one in this way. So here and next, there is an example for two different types of exceptions if we expect in the try block. There is two different catch blocks for a try block. First one is arithmetic exception for the statement like this, and next one it is array out of bound exception. So if in Java language, arrays are bounded respectively, so it generates an exception, it exceeds the boundary, that is out of bound exception. It may generate array out of bound index or out of bound exception. So this is one more example. In this way we can have nested try blocks. We can have nested try blocks in a try block. We can have another try block. But if there is a try block, we need to have a catch block respectively. Why? Because we expect an exception in the try blocks. That's why we need to have the respective catch block for a try block. This is the continuation of that program. So if we can use a number of methods in a method call, there may be an exception in the method definition such that we can use that method call within the try block, such that previously we have seen the stack traces, isn't it? So in this way we can use some other method call within a try block, and we can handle that exception which expects in a method definition. So catching exceptions in finally. So finally, it is a block. It is not a method. It is a block which will execute at the last of after try catch block. So finally executes at the last. So this is about the finally keyword. A block of code is always executed despite of different scenarios. So the exit occurs at the return continuing break. So this is about finally block. So finally it executes at the last after try and catch block. So this is an example for that one. This is one more example. and thank you.